Alright, hey again, YouTube. Sorry if I sound like crap. I'm sick. I probably got the COVID, but I needed something to do. So we are playing with this other reproduction board, the Melius. This is the version 1.1. DIY Chris made these things, and this is one of his prototypes. So there's already a 1.2 version where he's got a whole bunch of other neat stuff going on. But I had this half-baked idea, and I didn't want to butcher a real 64 board for this. So I had bought this board off Chris to kind of support his effort, and I figured one day if I wanted to dink around with something stupid, this would be the board I'd do it with, so I wasn't destroying something new and shiny and whatever. So a couple of little weird things going on. For the most part, I mean, it's a 407 board with some mods, really, at the end of the day. But right here, the 7406, you can't get them right now in the typical DIP 14 package. I had to get one of these surface mount chips. So I very gingerly tacked on a bunch of wires and put them on a socket, so at least I didn't have to part out another machine to get this thing to go. Other than that, it's got the 466 style memory, if you want to call it that, or like the 425 boards, where it's just a pair of chips. I have the SRAM kit I haven't put in yet. We'll play with that later. New logic chicks. Right now, all I got's the 6510, a PLA, and the VIC section populated. This board's pretty cool. It's got a built-in circuitry for modulator, and I just have a little RCA on some pigtails hanging out of the back of it now. I'll do something better later. But the fun part that we're going to get into here is in the power section. So my goal here is to build a machine that has a functioning clock for the real-time clock that's run by the CIAs, and is also able to be run off a single 12-volt input, right? So right now I'm feeding it about 13.8, 13.7, depending on the day of the week, and I'm putting that right into where you would normally have the rectifier. I did not populate the choke, fuses, a bunch of caps in here, rectifier, all that other stuff I left out. These two caps I did populate because that'll help smooth stuff as it comes in, and it still has the old school linear regulator. So I'll have more parts tomorrow to finish off the power section in this thing, so I can get rid of this this silly little 4005 buck converter and that kind of stuff, and it'll be nice and clean that way. And then once we get the power section all cleaned up the way I want it, we'll work on what we're going to do to feed 60 hertz into the clock. So there's a little intro for now. I'll get parts for the power tomorrow, and we'll start building from there. Alright kids, it's time for our fun with oscillator section of this video. So this little guy right here is a little circuit board I made up. It's just perf board, and I used a bunch of resistor legs to do traces and whatever else on the bottom side. But it's a really simple circuit. Everything revolves around, see if we can get some good light there, the Elm 440. This is a little cute all-in-one frequency divider reference oscillator kind of thing, right? So they designed it around using a standard crystal, 3.58 meg, the color burst crystal from an NTSC TV. Unfortunately, I don't have one, but I was able to salvage this, what is it, a 3.66 something. Came off this lava serial card thing I had laying around in the basement, old PCI card I didn't need for anything anymore. So all that to say, it takes the 3.5, 3.6-ish and divides it down to give you 60 hertz. And it'll actually do 1 hertz on the pin right next to it. So all that to say, we have ourselves a reference oscillator that will run off 5 volts input. So I think it's close enough for what we're doing for now. I'll have to order the proper frequency crystal, but I think this is close enough for a proof of concept run. So it's putting out 61.6 hertz instead of 60 hertz. All right, it's close enough to where the clocks will run. They'll be a little bit off, but it'll work enough for now. The 3.58 meg crystal that will go with the circuit is very easy to come by. I can order those off anywhere and have them here in a little bit. But I think this is good enough for now. We're going to find a spot on the board to hang this little guy And once I get the right crystal, I'll mount it more flush so it's not just dangling off the back and everything. But yeah, I think this will drive our 6526 clocks quite well. All right, here's a blown up schematic of this is the 9-volt AC coming in, and this is a little circuit that actually feeds pin 19 on the CIAs, and it's bridged to the other CIA. You can't see that from here, but point being is that this takes one leg of the 9-volt AC in, and that's where it's getting its 60 hertz from, and it comes through this a voltage regulator circuit. It basically uses a 2.7 volt zener to knock it down, and then it's going to run through the U27, couple of pins on that LS08, and that's what's actually going to drive the 60 hertz into the chip. It's not like the CIA is taking 9 volts AC and doing something with it, right? So all that to say, what I'm going to try first, and I think it ought to work, and it's probably the safest thing we can do, is I'm just going to lift the one side of R5 that goes up to the 9-volt rail. We don't want that 9-volt rail touching. There's nothing on it anyway, right? So, in fact, I lifted that resistor anyway just to make sure that rail wasn't connected to anything, because I got a whole bunch of open junk on the board right now. So all that to say, I'm going to take the output from this little oscillator gimmick we built and feed it right into the 560 ohm resistor, and then we'll take a look from there. And if it looks like we don't have enough to drive it, I think we will. You know, because think about it, if this is supposed to be 9-volt AC, we're feeding about 5-volt DC into the thing. Because it's there's some DC coupling coming out of that little 440 chip. But even still, going through this circuit, right here, it basically gets rectified and everything else, right? We have a diode going to ground and whatever else, right? So it should be fairly safe to feed into this LS08 through this circuit. Worst case, we blow up an LS08, but I got a bunch of those. I'm not too worried about it. Those are cheap chips. But so all that to say, there is our R5. It sits right below the ROM socket, so I peeled him off the board already, and I got this leg that's going to go out to our little oscillator board here. So that is going to give us our reference, hopefully, that the LS08 will like. So I'll probably shut off the camera. I'm just going to tack down our 5-volt and ground, and we'll get this thing rigged up to a TV, and we'll do some before and afters and see if the CIA likes this thing or not. All right, we're back, and I don't know how great this thing's going to work this way. All right, so when we look at, spin over the scope a little bit. When we look at this new oscillator going through that first 560 ohm resistor, we're pretty low. Peak to peak, we're only like 2.48. That's probably not going to be enough to drive the circuit. So I imagine we could do math and figure out exactly what we need to do to re-engineer the circuit, but I gotta be honest with you, I'm on a lot of NyQuil and bourbon. So, yeah, we're not going to do math. We're just going to step our way through the circuit. And if you look right after, back up here on our little schematic-y, after the 560K, we hit C200. He goes to ground. He kind of levels out the circuit a little bit. So, and then we hit that 2.7 zener. Right, so we're going to go right to C200, and if that doesn't work, we'll go the other side of it, and we'll go right into pin 2 of U27. But right now, looking at them, right, like, we saw what's going into the circuit there at what was he, R5? Yeah, R5. Now if we go to U27 on pin 2, it's even lower. I mean, we're 1.84 peak to peak. That's not going to be enough to drive this this TTL logic, and then 3 is the output, right? And we got big fat nothing on 3. Go back over to 2, we got our little bit in. That's just not enough hitting them, man. That is not going to drive this TTL chip. Maybe if we went with a what is it, the HC series of chips, the ones that you know, the tri-state kind of chips we might be able to do something creative with, but I'd rather not. I'd rather leave the leave this chip here. So let me check one more time. Yeah, there's nothing on 3. We got our weak signal on 2. All right, so we'll you know what, I'm just going to pop that resistor off, and we'll just put this line right into the board and see what happens. Maybe I'll shut the computer off to do this. Nothing says fun like drinking a bunch of bourbon, popping NyQuil, and soldering on a running machine, right? At least I remember to put on a strap. Alright. Take him out of there. Here's our little R5 pad. Alright. Fire him back up here. Oh, wakey, wakey, little TV. Is the machine still running? Yeah, that's good. Alright, U27 pin 2. Didn't come up terribly much. It's only a 560 ohm resistor. I wasn't expecting much. But yeah, and output on 3 is still absolutely nothing. So, we know we're not driving it too hard. You know what, let's just solder them right there onto pin 2 of the chip. Why not, man? That'll be fun. Let's see what happens when we do that. Take him out of there. And let's see if we got enough goo left on the wire. Now we need a little bit of tin on the leg of that chip. Just a wee bit up there. Come on, little buddy. There we go. It's ugly, but he's on there. Let's see if we get smoke. I don't see any smoke coming out of it. Alright, well, dead test still booted up. Let's see what we've got here. Yeah, so pin 2, we're really hot. We're 5 volt coming into it now, peak to peak. Oh, and look! Now we got our output to the CIAs looks good. So there is pin 19 on the CIA socket. Hopefully you can see that. Pin 19 on the other socket. So yeah, I guess we can bypass that entire damn circuit. We can just go right at, looks like R100's a 1K. You know, instead of having to go right onto the chip, we'll find R100 and bug them in there to make it a little neater. But I think before we do that, let's yeah, you know what? Let's do that first. Let's find R100. Let's move the wire, and I think we'll just feed the LS08 right out of this little board. All right, R100 was easy enough to find. He was right in here, you know, right below the 2.7 Zener and the that other R5. That's the one we ripped out. So going right in there, I mean, basically that's just wiring him directly into pin 2 of the of that LS08. So looking at pin 2, the input, you know, where peak to peak is like 5.2 volts. Seems pretty high. That means 2.5, so I mean that's not terrible. But the output is pretty much identical to it because we're not doing anything to that you know, circuit going in there anymore. We're just hardwired directly into the chip at this point, right? So if we look at pin 19 on the CIA slots, I mean, we, you know, other than the fact we're going through that little gate, it's pretty much a direct circuit now. So I call me paranoid, but I don't know how much drive the CIA likes on that pin to drive the clock. So we are going to let's shut this one off. We're going to sanity check ourselves. I have another bread bin here that had a bad CIA in it at one point, so he had a socket and all that, so I pulled one of the CIAs out. And granted, we still have a CIA in there. They are wired on the same circuit, so it might be a hair lower, and that's okay than you know what it is we're kind of looking for. But I want to look at a working board, because I call me paranoid, man. The last thing I want to do is blow up CIA, man. They are hard to come by. All right, I rearranged some wires. We got a good ground now, and yeah, we're only hitting the chip at what, call it 3.8 peak to peak. We're gonna put something back in line, one of the resistors. Maybe we'll put that 1K back in line with it, and see what we can do to get that to drop down a little bit. I don't want to drive these CIAs any harder than I absolutely have to. So I'm gonna clean this junk up, and we'll find a better way to rework that circuit to drop the voltage a little bit, so we're not beating the crap out of the CIA too bad. Alright, I just spent the last 20 minutes screwing around with this, and finally I just said, you know what, to hell with it all. Why do we need any of this stuff in here? I mean, everything in this circuit was really designed to, you know, take your AC voltage, strip the AC out of it, keep the 60 hertz, and deliver it to the CIA. That's basically what this little device here does anyway. So I think we can do away with all this crap. So all that to say, on the LS08 here in U27, actually lifted pins 2 and 3 out of the socket, so that gate's not even in the mix anymore. And then we took out R100, R37, R5, and that diode CR1. And R37, the right side pad on there goes directly to pin 19 on both of these sockets. So all this crap is gone now, and we just have our cutesy little oscillator and a CIA. So let us see what that does. All right, we got time. It's a clocking. Doesn't feel ridiculously warm or anything. Let's take a look at 19. All right, so we're 2.48 volts. You know, a little over 5 peak to peak. I don't understand that. At any rate, you know, at 2.5 volts mean, I don't think I'm worried about blowing anything up. And looks like time is tracking, so we've successfully got a working CIA with nothing more than 12 volts coming into this board. So I'd say that's an accomplishment. Like I mentioned earlier, I have more different regulators coming in tomorrow that I can clean up all this crap with. I think what we're going to wind up doing is yanking both of these, replacing them with these little switch mode gimmicks that I got, and we'll have to run some kind of bodge or whatever over to the 5-volt in for the rest of the board. You know, this regulator only serves the Vic and Sid and whatever, so we'll have to jimmy something off of him into the 5-volt to feed the rest of the board. But then I think we'll have a very versatile little machine that'll run on a multitude of input voltages and have working clocks. The other thing we'll dig into a little bit later is the tape port. I don't I don't know if we can get that thing working or not. I don't know if it requires the AC or not. I don't really care about tape decks, so I don't know how much effort I'm going to put into it, but I will try and see if we can get that thing working too. So anyway, that's it for now. I'm due for another dose of NyQuil and I'm going to bed. So take it easy, everybody.